Today we're answering some modulus questions that tend to cause some problems. So to start with, f of x equals 2 modulus x plus 1 minus 3. The vertex of the graph is at point P in the question. Okay. Find the coordinates. Okay, well, what we're going to do is we're going to say that this bit must always be positive. 2 times something that's always positive is at worst 0, isn't it? But this kind of comes later. This is minus 3. So this point here is going to be minus 3. And if you don't believe me, throw in a value of x equals minus 1, and you will see that that is the smallest that you can ever make the first part. You can make it a 0, and then take away 3, gives you minus 3. We've also just stumbled there, haven't we, on the x value. So the x value is always sort of the opposite sign with the other part that you have there. Again, the idea is when you apply the modulus to something, wherever's inside here is always at least 0. So subbing in x equals minus 1 is when you make this happen for the first time. Okay, so the first part there is going to be minus 1 minus 3. Let's make sure we clearly answer it because it says find the coordinates. So minus 1 minus 3. Solve the equation 10 minus 3x equals f of x. So f of x is the name of the thing we had before, whereas 10 minus 3x is something that's new. So a good first step would be to roughly kind of place this. Now, what was it? It was 10 minus 3x. Right, well, 10 is, all the way up here somewhere, and minus 3x. So I don't know exactly what this will look like, but my guess would be that this is a graph that looks roughly, maybe something like all the way up here is 10, and it's quite a steep negative line, okay? In fact, it should be steeper. It should be steeper even than this line over here. I can see 2 and x. So, this, for reasons we'll get to in a moment, that line that's there already has a gradient of minus 2. So it looks sort of something like this. Now, why is that useful? Well, it's useful because it tells me how many times the lines are going to intersect. They're going to intersect over here. Do they ever intersect up there? Well, no, because this line is sort of shallower than this line is over here. So to the part of the screen that you can't see, to the left, they'll never meet. And you do need to think about stuff like this. So I'm confident to say that there's only going to be one solution here. Now, how do I go about finding that? Well, I noticed that this is sort of a line on the original graph that's going up. So we have to consider 2 cases with modulus functions usually. We have to consider the case that it was sort of 2 and then the bit inside was kind of always positive, which would be a straight line like this, okay? So this is sort of, I'm going to call this here the unreflected case, okay? Because you're kind of just ignoring that modulus bracket, you're kind of just expanding it out, okay? So the unreflected case is a little bit like 2x plus 2 minus 3. It's a bit like we're looking at the line 2x minus 1, and you can see that if we go back, 2x, there you go, there's minus 1. So this line over here seems to be 2x minus 1. The only catch is you can only use 2x minus 1 to the right-hand side of this point here. So this is only valid for x is greater than or equal to minus 1. Okay, so that's one case. Now, the other case we have to generally explore is when what was inside the brackets would have actually been negative before it was expanded out. So you can kind of do something like this to investigate that. Okay, so once is with just the positive of the number, and the other time when you want to invest the other part, you do the negative of the number. That's how I like to answer this question anyway. And then minus 2x, minus 2, minus 3, you get minus 2x minus 5. So this is the sort of reflected, yeah, I'm going to kind of call this the reflected, it's sort of the negative case. And you can see that again on here. So this line, we're saying, if it kept going, which it doesn't, but if it did keep going, it would go through the y-axis at minus 5. And you can see clearly that it's got a negative gradient. The catch is, though, that you can only use that line to the left-hand side, can't you? Okay, so this is only when x is less than or equal to minus 1, whereas this is when x is greater than or equal to minus 1. Okay. Now, that means that we could just solve everything and check that they follow the rules, but knowing what the graphs look like means that we don't need to do that. All we need to do is we need to look at this. This is the sort of the unreflected case, I'm calling it, the right-hand side. We need to look at that, so that's 2x minus 1, and we need to look at it with this new part here, and then we just need to check that when we put these parts together, it is in fact to the right-hand side, which it should be. So now we know all of that. Now we've done the detective work. Let's write it out. So 10 minus 3x is equal to 2x minus 1. So I'm going to say 11 equals 5x, x equals 11 over 5, or 2.2. And if you look at our graph here, remember this is just a rough sketch that I was doing, you can see that we kind of seem to have the right answer. Okay, so 11 over 5 is to the right, so this is fine. This passes all of my tests. And just to show you, I'll just sort of show you that the one on the left wouldn't work, just to kind of experiment. So let's solve the case one more time. 10 minus 3x, and let's solve it with the reflected case, which is minus 2x minus 5. So let me just show you that that doesn't work. So if you add 3x to both sides, you'll get, and you add 5 to both sides, you'll get 15 equals x. Now that's a problem. That's a problem because this line here only exists, doesn't it, to the left of minus 1, and that clearly is much bigger than minus 1. So that's why that one there would not be okay. So you can kind of think about some of these questions graphically, or you can think of them by thinking about their domain, is what I'm doing there. Anyway, we've covered a few important points. So we've got the minimum point here. We've got solving questions, you know, the two different cases, how we would handle the algebra and how we check which one it is. And finally, we've got a new question. So we've got a line with equation y equals mx, so m seems to be unknown, plus 2, where m is a constant. It's going to intersect the line from before at two distinct points. Okay, so let's just get rid of the previous stuff to help us think about what's going on. So I'm going to get rid of all of that part there, and let's have a think about it. So this line plus 2, well, plus 2 is sort of up here somewhere, isn't it? And the gradient is unknown. So let's just try a line on here and see what happens. So let's imagine that the line was something like this. It would cut through at two different points. So this is the kind of situation that this question is asking me about. So, well, how do I answer it then? The trick's going to be, let's start by thinking about some cases, some lines there that wouldn't work. So let's try a line that wouldn't work. Here's a line that wouldn't work. Something, I mean, that's not quite what I was going for. I wasn't going for an asymptote, but something like this would not work. So why would this not work? Well, it only has 1. And up here, you can see that they're getting, because this is so steep, they're getting further apart from each other. So they're not going to intersect anywhere else. So what's creating this scenario? Well, it's about the gradients between the two of them, isn't it? Because if I did, so the gradient of this line, remember, is 2. We discovered that from earlier. So if we did something less than 2, eventually, although it might not be on my screen, they would intersect, wouldn't they? Eventually. So I think the first condition I think I've just discovered is that the gradient needs to be less than 2, doesn't it? A gradient less than 2 gives me a scenario like I've got here on the screen, where they're going to cross here and they will already cross over there. So if I want them to cross twice, the gradient needs to be less than 2. But I should think about the other way around as well. So let's think about some negative lines. Well, that one there, for example, is crossing twice. When is it going to stop crossing? It's going to stop crossing, again, once these lines become sort of parallel to each other. Because even off the screen, if that happens, they'll never quite meet. So the answer to our question is as follows. When the gradient is between the parallel lines, eventually, even if it's way off to the right or way off to the left, they will cross, and it will cross on the other side as well. So the answer is -2, and between -2 and 2, not including the values, because then they're parallel. So this kind of question here, you really have to sort of like put a ruler on the diagram and reason your way through it. Now, I've got one more question that's similar, and I'd encourage you to have a go for yourself to see now if you can put the same skills into action.